Good morning, students. In previous lecture, we have seen the vapor absorption system. Now, in a vapor absorption system, we have seen the points to be covered. Next, we have seen the um, desirable properties of the binary mixture, and we have seen the um, vapor absorption, ideal vapor absorption system. Now we are going to discuss the actual or we are saying that it is the practical vapor absorption system. The simple absorption system we have discussed, the simple vapor absorption system designed for continuous operation, as we have discussed previously, which is we are finding that which is not economical unless its performance is the improved. So some kind of the improvement we have to need to do. So the simple vapor absorption system is not economical. So in order to make the system more in actual practice, it is fitted with an analyzer, rectifier, and two heat exchanger. As you can observe here, this is first heat exchanger we are finding. This is first heat exchanger we are finding, and this is second heat exchanger. Also, we are finding the rectifier we are introduced. Next, we have make these more and more practical, and we are also introduce the analyzer in this system. So analyzer, rectifier, and two heat exchangers we have introduced in this cycle. So these has accessories help to improve the performance of the cycle. Now one by one we are going to see the application and how it works. Now, first we are going to see the analyzer. So it is possible that ammonia vapor leaving the generator may contain the water vapor. We are finding that from the generator, some vapors contain the liquid ammonia vapors. So the water vapors will be also contained over there. So the condensed water may freeze in the expansion wall and choke the flow. So it is necessary to remove any moisture from the ammonia vapor before entering the condenser. So the analyzer performance the work of removing the moisture from the ammonia vapor leaving the generator. So in the analyzer, it consists of the series of trays. Okay, we are finding in the analyzer series of trays mounted over the generator, and it acts as a open type heat exchanger. So the high pressure strong aqua solution from the absorber via aqua heat exchanger along with the condenser removed in the rectifier. So in the rectifier flows down over the trays, and it cools the hot rising ammonia vapors from the generator. So therefore most of water vapor gets condensed and drip back to the generator. So this method helps the salvaging a part of total heat energy from ammonia vapor, which otherwise would have been rejected in the condenser. So we are finding that to improve the performance, analyzer we have provided, and it will be it helps to most of water vapor get condensed and drip down back to the generator over here. So this is the function of the analyzer. Next is the rectifier. Additionally, we have provided in case of the rectifier, the water vapors are not completely removed in the analyzer. Partial will be removed. So the enclosed type vapor cooler, which is called as also rectifier in some cases, we are also calling it as a dehydrator. Okay, so it is generally water cooled and maybe of the double pipe, or we are saying that shell and coil, or we are saying shell and tube type. So its function is to cool the further ammonia vapors leaving the analyzer. So remaining water vapors are condensed in the rectifier, or we are calling it as a dehydrator. Okay, so the condensate from the rectifier is returned from the rectifier to the analyzer and drifts into the return product. So this is the function of the rectifier. Next is the heat exchanger. First is exchanger we have provided. The heat exchanger provided between the pump. You are observing over here pump. From in pump and the, we are finding that it is provided between the pump and the generator. So it is used to cool the weak hot solution returning from the generator. So you are finding that the heat exchange takes place between these two. So as we are finding that we are supplying the heat to this solution, so the solution which is introduced in the absorber, so the heat is absorbed from that solution, and it will be supplied to the solution which is supplied to the generator over there. So the heat removed from the weak solution raises the temperature of the strong solution leaving from the pump, okay, and going to the analyzer and generator over here. So this operation reduces the heat supplied to the generator and the amount of cooling required for the absorber, so which increases the economy of the plant over here, and it helps the reducing the heat supplied to the generator, and cooling is provided in the absorber over there. So this is the function of the first heat exchanger. Next, this is second heat exchanger, which is we are also calling it is as a liquid vapor heat exchanger. The heat exchanger provided between the condenser, okay, between the condenser and the evaporator. So that's why it is called as the liquid vapor heat exchanger. Okay, sometimes it is called as a liquid subcooler also. In this heat exchanger, the liquid refrigerant leaving from the condenser is subcooled up by the low temperature ammonia vapor from the evaporator. So this subcooled liquid is now passed through the expansion valve and then to the evaporator. You are observing over here. Here heat exchange takes place and it's passed through the evaporator, sorry, expansion valve, and from expansion valve to evaporator. So it helps reducing the temperature of liquid ammonia approaching to the expansion wall, so that an increased refrigerant will be observed in the evaporator. So the COP of the system is definitely increasing. So the net refrigerating effect of the system is also increasing over here. So the total energy required to operate the system is equal to the sum of work energy required to operate the aqua pump and the heat energy supplied to the generator. So only these two will be, we are finding the energy supplied. So COP, we are saying that refrigerating effect upon the work energy supplied to the aqua ammonia pump to plus heat energy supplied to the generator. So we are finding that by using the heat exchanger and analyzer and rectifier, the maximum COP will be getting and refrigerating effect will be produced is the maximum. So as we have seen previously, the strong ammonia solution is supplied to the absorber. From this absorber, pumping action will be takes place, and after pumping here, it will be entered into the heat exchanger. So it will absorb the heat from this weak solution, and it will be supplied to the analyzer. And in the analyzer, again we are finding that perforated trays will be provided, and only vapors will be supplied. So strong ammonia and H2O solution containing less amount of H2O vapor will be passes from the analyzer, and from the generator here we are supplying the heating coil, and vapor it will be converted into the vapor strong ammonia H2O solution. So the weak solution will be passing through the heat exchanger via pressure reducing valve to the absorber. So then here we are finding that as we further we are supplying this solution, and here in the rectifier and dehydrator, the we are removing the generally we are removing the cool ammonia leaving, and in the dehydrator it is again supplied to the analyzer over there. Okay, so the function we are finding in this dehydrator is to cool further vapor ammonia leaving from the analyzer, so that the remaining water will be condensed and it will be again supplied to the analyzer over here. So strong ammonia vapors will be supplied to the condenser, and in the condenser again heat exchange takes place, and strong ammonia vapor will be converted into the strong ammonia liquid, and which is collected into the receiver. And after that, this strong ammonia liquid is passing through the heat exchanger second, and here heat exchange takes place, and strong ammonia vapor is extracting the heat from the strong ammonia liquid, and this solution is passed through the expansion wall, and strong ammonia liquid is supplied to the evaporator, and in the evaporator heat exchange takes place, and strong liquid ammonia is converted into the strong ammonia vapor, and it will be again passed to the heat exchanger, and it will be supplied to the absorber. So this is the actual, or we are saying that practical vapor absorption system. So as we have discussed these points in this simple vapor absorption system, that is where is the location. So whenever we are supplying the heat exchanger, it will increases the economy of the plant. Also it will increases the efficiency of the plant, and COP, as I have told, COP is equal to heat absorbed in the evaporator. So here this is desirable output which we have to require. We require the cooling effect or refrigerating effect. Okay, upon the we are finding that work done by the pump plus heat supplied in the generator. So work done by the pump means the pump required to drive this pump, and heat supplied in the heating coil. So these two are the input and desirable effect we are getting over in the evaporator. So COP of this vapor absorption system is heat absorbed in the evaporator upon the work done by the pump plus heat supplied in the generator. So this is the simple vapor absorption or practical vapor absorption system we have discussed. Now next point we are going to see the three fluid vapor absorption system. Now, in this three fluid vapor absorption system, we are also calling it as a Electrolux refrigeration system. So, in Electrolux refrigeration system, the refrigerators, we are finding that Electrolux refrigerator is used or is such type of a system uh, of the vapor absorption system which does not require the pump, so it reduces the amount of power input to the system and the efficiency of the system is improving. So the flow of working fluid takes place by the action of gravity itself. Besides that, the hydrogen gas is used to improve the performance of the evaporator. Okay, so we are finding that the domestic absorption type of the refrigerator was invented by the two Swedish engineer, that is the Carl Munters and the Walter Von in the 1925. And the Electrolux refrigerator is used as a domestic refrigerator, and this type of refrigerator is also called as the three fluid refrigerator, because you are finding the three fluids we are using, that is the ammonia, hydrogen and the water. The main purpose of this system is to eliminate the pump. So in absence of moving parts, machine becomes noiseless. So the ammonia used as a refrigerant because it possesses most of desirable properties. It is toxic, but due to absence of moving parts, there is a very little chances of leakages, and total amount of refrigeration used is the small. So we are using the ammonia. Next, the hydrogen. Hydrogen being is the lightest gas, and it is used to increase the rate of evaporation of liquid ammonia passing through the evaporator. So the hydrogen is non-corrosive and insoluble in water. So this is used in low pressure side of the system. So the water is used as a solvent because it has the ability to absorb the ammonia. So we are using the three fluids. So the principal operation of domestic type refrigerator we are going to discuss. First of all, we have seen the three fluid, why we are saying it as a three fluids and why we are using the three fluids in this system. Now, we are going to see the principal operation of this domestic refrigerator. So the strong ammonia solution from the absorber is we are going to be supplied through the heat exchanger is heated in the generator. So strong ammonia solution we are going to supply to the generator from the heat exchanger. Okay, so during this heating process, ammonia vapors are removed from the solution and passed to the condenser, and a rectifier or water separated we have fitted over here, and the function it removes the water vapor carried the ammonia, so it will be again supplied into the generator. So the water vapor will be removed and only high pressurized strong ammonia vapors will be supplied into the condenser. So the dry ammonia, we are finding that the dry ammonia vapors are supplied to the condenser over here. The hot weak solution left behind the generator flows from the absorber Okay, so from the here we are going to supply the weak solution of ammonia again to the absorber via heat exchanger. So this again passing, we are finding that this passing again this hot weak solution while passing through the exchanger is the cooled. So we are finding the function of single heat exchanger we are using, and the heat removed by the weak solution is utilized to raising the temperature of the strong solution passing through the heat exchanger. So in this way, absorption is accelerated and the improvement in the performance of the plant is achieved. So next, the ammonia vapors in the condenser are condensed, and by the external cooling we are going to be supply external cooling source, that is cooling water we are going to supply in the condenser. The liquid refrigerant leaving from the condenser is flow under the gravity to the evaporator where it meets the hydrogen over there. Okay, so we are finding that the hydrogen gas which being fed by the evaporator permits the liquid ammonia to evaporate in the evaporator at low pressure and temperature according to the Dalton's principle. So during the process of evaporation, the ammonia absorbs the latent heat from the refrigerated space. So thus here cooling effect will be produced, and the mixture of ammonia vapor and the hydrogen is passed to the absorber where ammonia is absorbed in the water while the hydrogen is rises on the top and flows back to the evaporator. So it will be completes the cycle over here. So this is called as the three fluid system. Once again, I am repeating, strong solution ammonia is supplied from the heat exchanger to the strong solution, and here in the strong solution generator, in the generator it will be supplied and strong ammonia solution is converted into the high pressurized ammonia solution, and weak solution again supplied from heat exchanger to the absorber. So again here we are providing the rectifier. In the rectifier we are finding that we remove the water vapors carries with the ammonia vapors, and high pressurized strong ammonia vapors will be supplied to the condenser. Here cooling will be providing, and after condenser it will be strong ammonia liquid solution is converted and it will be introduced into the evaporator, and in the evaporator we are finding that the hydrogen which is being fed by to the evaporator permits the liquid ammonia to evaporate as principle, and during this process of evaporation ammonia absorbed latent heat from the evaporator and produce the cooling effect. So here again mixture of ammonia vapor and H2 is supplied to the absorber, and hydrogen goes in the upper side, and the strong solution as ammonia again supplied to the generator. So this is the three fluid vapor absorption system we have seen. Next point, we are going to discuss the COP of this system. So as this COP of this system is heat absorbed in the evaporator, this is desirable effect, and desirable input is the, we are going to supply the heat in the generator. See, in previous cases, we are using the pump and the pump input and the generator input. This is the total input, and we are getting the evaporator as a output. But while we are seeing that As there is an absence of the pump, we are finding that the COP of this system is in heat absorbed in the evaporator to the heat supplied in the generator. So the advantages of this domestic Electrolux refrigeration system or three fluid system is completely leak proof, noiseless, no lubrication problem, no wear and tear, no pump and compressor is required, maintain cost is low, easy to control and simply controlling heat input. So these are the advantages, and disadvantage is more complicated construction and working principle. Coefficient of performance is very less. Other the system spoiled, it cannot be repaired or it has to be replaced. So any component in this system, if get spoiled, then we have to replace. So COP less, more complicated, and in construction and working principle also. So these are the disadvantage of this system. So these all about the today's lecture. So in next lecture we are going to discuss LIBR system. So this is all about the today's lecture. In today's lecture, we have seen the actual vapor absorption system, and we have seen the three fluid Electrolux refrigeration system. So this is all about today's lecture. Thank you very much.